So today we've got quite a bit of a tag team effort from NeSI, which is the National eScience Infrastructure for those that aren't aware. So we've got Brian, Chris, Georgina or George,
Yep.
George and Alexander. So they're going to basically take you through tell us what NeSI's got to offer us and how we can get involved and use it. I think we're starting with Brian,
Yep.
are we?
Yep.
Given that there's all a bit of a tag team, maybe you could just say who you are when you hop up and,
Sure.
rather than me have to
Yep,
go off
absolutely.
now,
Yep.
and then I guess we can get cracking with it.
Cool. Great.
So we'll leave it to Brian.
Great. Thanks. So, so I think probably the best thing to do is to make this a discussion rather than a one-way presentation. So I'm quite happy to stop and answer questions at any time. This is kind of an information session for us to tell you about NeSI, but also for us to learn about what you do. So if you have any questions or comments or thoughts, please feel to interrupt. So I'm the solutions manager for NeSI. So I manage the group of people within NeSI that are researcher facing, so that are working with the researchers to help them support applications on our machines. So let me ask a question first of all. How many people here know what NeSI is? So quite a few of you. Okay, good. So NeSI stands for the National eScience Infrastructure. So we are a resource provider for high-performance computing to the national research community in New Zealand. And we're basically spread across multiple institutions. I'll go into that in a little bit later. But our mission is basically to help support researchers do their research more effectively, in particular if you're a computational science user. So if you use a computer as your main research tool, NeSI is an organization that could conceivably help you. And so hopefully we'll give you some information on what that means. If that is meaningless to you and you don't know what the heck I'm talking about, hopefully that'll become a little bit more clear as we go on. So we're going to talk a little bit, kind of the focus is from taking your computational science research, so the research you do on your desktop computer today, if you're struggling with the kind of things that you're trying to accomplish on your desktop computer, and move it into the HPC world or the high performance computing or the cluster world. So using larger computers to do more research faster, bigger, better, stronger, however you might want to look at that. So we're going to talk a little bit about what HPC is, high performance computing, and who NeSI is. Chris is going to talk about a couple of case studies, give you an idea of kind of some of the things that we can do to help you do your research. Talk a little bit, I'll come back on and talk a little bit about accessing the NeSI infrastructure a bit more. And then Alexandra is going to talk about kind of how we help develop and support our research communities in terms of training and outreach and things like that, so you can understand how to get access to our systems and better prepare yourself as a research group or research organization to help use computational science tools in general and NeSI in particular, if that's... and then we have Q&A, but like I say, anytime you want to ask questions, please feel free to jump up and down and wave your hands and things like that, and I'll try to answer them. So high performance computing and research, basically the context of what we're talking about is if your research involves complexity, things like climate change, geoscience, bioinformatics, I stuck bioengineering in there, just thought that might be relevant. And if that research involves complex simulation, modeling, or data processing, you're probably a big computer user in some way, shape, or form, and you're probably using computers for your research. And so that's kind of the domain of high-performance computing. If you're using software and you require larger computers, then you're a candidate for using HPC as a tool for your research. And so we'll talk a little bit more about that. So is this for you? So how many people here, everybody uses a computer to do their research today. How many people would say that you use a computer that stresses your current system that you're using today? You don't have enough memory, you don't have enough processing power. Just quick, raise your hands if you're kind of pushing the limits of what you can do on your desktops. So you're probably doing that through either doing data analysis or some sort of modeling or simulation, right? if you're using some sort of software packages, and I believe ABI has a pretty large software suite that you guys have developed locally. These codes probably are stressing your computers in terms of the types of analyses they're doing. So if you want to be able to scale up, HPC might be for you. One of the things that HPC can do is, so if you're running something on a small computer, it might take a long period of time, but if you want to do 1,000 different things on a single computer, you got to run them serially on a single processor on your laptop. You might want to scale that out to large numbers of simulations and things like that. So HPC can allow you to be much more productive and effective. You can get a lot more done by running a lot more things in parallel. We'll talk a little bit about that later. And one of the big things I think for a lot of people that are struggling with is you want to tackle more complex problems or larger data sets. So you want to raise the resolution of your simulations. You want to tackle more complex, more variables in your simulations. So you want to be able to basically advance your research beyond what you can do today on the technology that you're using. So anybody have any questions about any of that, or any thoughts, comments? Yeah, I think people are kind of nodding their heads saying, yeah, I think I maybe could use some bigger, stronger, faster. So some of the things people will struggle with is having enough memory in their computers to do the simulations that they're working on. You might need, your data sets might be very, very large, or you might be generating very large data sets. You need to analyze those data sets. So you need to have more data storage available. Your simulations might take an awful long time to run. So, all of those kind of situations are candidates for using different types of computational resources than maybe what you have available to yourselves. So NeSI basically is a consortium that's funded by the Ministry of Business, Innovation and Employment, and is basically a partnership between the University of Auckland, University of Canterbury, Landcare Research, University of Otago, and NIWA. NIWA is the National Institute for Weather and Atmospherics, based in Wellington, but they're actually spread across the country, so they're one of the big CRIs. And basically, the mandate for NeSI is to bring together a set of resources. That's technical resources, so computing resources, but as well as personnel resources to help you do your research better. And that's one of the key things, that it's not just a bunch of hardware, but there are also experts like Chris, who is here, and he talk about some of the work that he does, the type of work that they do, and that's to help you optimize your codes. So it's not trivial necessarily to go from your laptop to an HPC machine. Sometimes there's a lot of work that needs to be done. Sometimes you can do that easily, and you can just run lots and lots of different simulations in parallel, but sometimes you have to do a lot of work to scale up to large data sets or large number of processors. So there's a lot of people resources within NeSI that can also help you do that kind of work. Any questions? Please don't be shy if you have questions. I'd much rather have a dialogue than just stand up here and talk. So NeSI basically has two large machines at the moment. In the past, we had a couple of other ones. We just actually decommissioned a couple of our machines, and we are just about to go into the procurement process for upgrading our two main machines, one located at the University of Auckland here, and one located at NIWA in Wellington. And these are large machines. So the PAN machine has over 6,000 processors, and the Fitzroy machine has over 3,000 processors. So these are very, very large machines that you can scale out very, very large codes to if you so choose. There's two kind of high-level types of machines. There's a capacity machine. They're targeted at running large numbers of small jobs. So if you have a small job that you're running on your laptop, and you want to run that, and you want to do 10 different analyses, and each one of those takes a day, and then you say, okay, I need to scale up my problem, and I want to do 1,000. And all of a sudden, your jobs are going to take 1,000 days, and it's going to take you 3 years to complete the work. If we put that on 1,000 processors, they'll be finished in a day. Right? So if scaling up that kind of workflow and codes can be very easy, I'll be the first to wave a big red flag and say it's not always that easy. But that's the type of workflow that works well on this capacity machine. A capability machine basically is targeted at running a small number of very, very large jobs. So a single job working on a very, very large problem in parallel. So these are fundamentally very different architectures, and they might be more appropriate for different types of workflows. And one of the advantages of having an organization like NeSI is that we have the expertise to help you figure out which machine you should be running those workflows on. Right? So we can sit down with you, talk about your project, talk about the types of codes you run, and help you decide which architecture is the right one, help you choose the software solution that you're going to use, help you tailor that solution, and help you tailor your workflow potentially on how you're going to run it. I won't go into details of the hardware. I'm happy to talk about that after the fact if people are interested. So any questions about that? I did mention that, so both of these machines are on the order of, well, different bits and pieces of them are on the order of 4 to 5 to 6 years old. We will be running an RFP and procurement process over the next year, and both of these machines will be upgraded fairly substantially. So there is a lot of computational resources available to researchers in New Zealand. If you don't know that, this can be a very, very valuable resource for you as a researcher.
Is there still going to be that distinction between machines with the ability to essentially run many things in parallel as opposed to having a lot of communication?
Yes, yes. There will be difference, and the main reason for that is some problems don't scale well on this type of architecture, and they scale very well on this type of architecture. So these climate codes are traditionally types of codes that don't scale very well unless they have a really, really fast interconnect, very low latency fast interconnect. We will have both platforms because the research spectrum basically has both types of research workloads. And so, this is a very expensive machine. So if you buy just that, you're wasting dollars on interconnect if you're running this type of workload on it. So it's better to try to split up the machine into kind of the less expensive, lower speed, still high speed interconnect, but lower speed than the really high-end machine. Yep.
In the big wide world of HPC, I mean, these machines kind of, a few others but where do you go, even from an Australasian perspective?
No, it's a great question. I'm actually from Canada, and I come from Compute Canada, which is the New Zealand equivalent of NeSI. Canada is about 10 times the size and population to New Zealand, and we don't have 10 times the number of CPUs in Canada than New Zealand does. It's not really a fair parallel because to get to a certain scale, you have to be at a certain scale, but New Zealand is doing relatively well in my opinion. We don't compare to Japan and China and the US, but certainly from a per capita, I think probably New Zealand's doing fairly well. Any other questions? Cool, so I'll just hand it over to Chris. He'll talk about a case study. I think you get to do that.
Cool. Yeah, so my name's Chris, and as Brian mentioned, I work as a scientific programmer for NeSI. So as part of my job, it involves going out to research groups and working with them to make sure they get the best use out of NeSI's facilities. So this can involve sort of developing software for them or optimizing software they've already got. And in this example, I'm just going to talk about, the next two slides, I'm going to talk about a project that I've been working on, which has been a collaboration between NeSI and a research group in maths, so James Sneed's research group just down the road. So yeah, I only started working on this project fairly recently, and a lot of the original work that was done on this was done by John Rigris when he was working for NeSI. And really the overall aim, the science goal for this project was to do physically accurate modelling of this parotid acinar cell, which is used in saliva production. And this, on the right there, you can see a model of this cell, which is quite a complex structure. So the first thing we do in this model is we break it down and we look at developing a model for the single cell initially. So we look at modelling one of those individual red cells. These cells are held together by the green tube-like structures, which are called lumen. And so the first thing John did on this project was he took they got a set of image stacks, so 2D image stacks from Microscope, which was brought from a collaborator in the US, and John developed this realistic 3D model of the structure. So then the way we're going to model these cells is by using reaction diffusion equations, which gives you a set of PDEs that you can solve using the finite element method. And the researchers are interested in the calcium dynamics within the cells. So it's known that you get calcium waves forming within these cells, and these calcium waves are what drive the saliva production. So on this slide, I'm just going to talk a bit about the implementation of the software that we did for this research group. So it was decided to write a custom C++ code. We chose C++ because it's high performance, it's easily extensible because it's object-oriented. So basically what happens is we're modelling one of those individual cells first. Once we've defined how one of those cells behaves, which is an object in the C++ code, we can then, in order to model the full structure of 7 cells, we just have to say how the cells interact with each other. And the idea is to have a really high performance library. So we want it to run as fast as possible, and the way we are going to do this is by parallelizing the software. So the strategy we came up with was to model one of the individual biological cells on a compute node on the cluster, and we would look at parallelizing within that compute node. So we would use either accelerators like GPUs or Xeon Phis, or we would look at CPU-based, like thread-based parallelization like OpenMP. And then we would scale out to multiple nodes on the HPC machine by putting 1 cell on each node. We've got 7 cells in total in this case. Oh, yes.
What GPU are you used for this, and what you are comparing with? What speed up compared with a normal CPU? Or?
Oh, you mean in this section here? So the speed up there is to the serial version. I'll talk about this quickly now, actually. So yeah, in these finite element methods, most of the time is spent solving the sparse linear system that comes from the finite element method. So one of the first things we did was look at different implementations of solver libraries. So we're using a GMRes solver, and there are many libraries out there that have GMRes solvers in them. So we wanted to find a library that could use GPUs and could use OpenMP, other parallelization options, so we could do a comparison for this research group. And we chose a library called VienaCL in the end. I looked at a range of different libraries, but VienaCL was the library we chose. It's a very lightweight C++ template library, so it's headers only, it's easy to include in your program, and it has a range of different options. You've got GPU options, you've got OpenMP parallelization and OpenCL, so there's a range of different options for different devices that you can use. And yeah, we did a range of benchmarking, so we looked at different parameters for the different method, the GMRes method, and different preconditioners, and the best result we got was a 2 times speed up using GPUs. That was compared to the serial version of the code. You get about a 1.6 times speed up using OpenMP, for example, so you still get a speed up just by using CPUs. And the reason we think, we'd hope to get a better than 2 times speed up, but the reason is you're not parallelizing the whole algorithm. The GMRes algorithm itself is a serial algorithm where you have to go through each step. The things that you're parallelizing are the BLAS operations, like the sparse matrix vector multiplications. So you're not actually parallelizing the whole thing, so a 2 times speed up we're quite happy with in the end. The second thing we really looked at is profiling. So I guess this example should show you that if you haven't profiled code that you've written, it's a good idea to do so, because it can show up things that you weren't sure about, that you didn't know about, basically. So when I profiled this code, we'd expected most of the time to be spent in the sparse solver solving the linear system. But actually, when I looked at it, only about 15% of the time was spent in that part of the code, and about pretty much the rest of the time, so about 84% was spent doing a matrix vector multiplication outside of the solver. So when I went and looked into it, there was at each time iteration, it was multiplying a dense matrix by a vector, even though the matrix was a sparse matrix. So just by pretty much a 1-line change to change that dense matrix to a sparse matrix gave an 8 times speed up in the code. And that wasn't obvious just from running the code. It was only when we profiled it we could see that this was happening. So it just goes to show that profiling is very worthwhile, and it's something that's very useful to do. And at NeSI we have lots of people who are very experienced in profiling code. Another thing that was really important to the research group in this case was testing. They wanted to know that if they run their code on the machine, that it's going to give the right answer, the expected result. One way we can do this is, so for example, if say a library gets updated, it might somehow break the program, and they wanted to make sure that this didn't happen. So I set up a weekly test that it runs every week automatically, and it emails out the result to the research group. So it's a full test of the code. We have a known output for a given set of parameters. We run the test, and if parameters don't match, it fails. If the result doesn't match, it fails. And so this runs every week on the machine now, and it gives them confidence that the results are going to be correct. The second thing we did was also use continuous integration. So continuous integration is where every time you commit a change into your repository and push that change, it runs the test suite. So you find out basically if any commit you've made has broken something. Because this software was developed as open source software on GitHub, we used a free service called Travis to do the continuous integration, which is a really good service, and it has good integration between GitHub and Travis. So basically every time we push to the GitHub repository, it runs a test on Travis, and it'll send us an email if it fails. This is really useful, especially when you're doing collaborative development. So we're developing this software as a collaboration with a research group. So we know that when we're merging changes together, for example, we know straight away if it's broken something. So this was another very useful feature that we added into this project. And the last thing I'll mention is a user runtime environment. So the standard use case for this research group was to do parameter sweeps. So you might vary 2 parameters, say, and give 5 values for each one. So that's a 5 by 5 parameter sweep. For the 7 cells, that's 175 simulations in total. So it's a large number of simulations to be setting off manually. So we developed this environment where you have a set of Python scripts where it'll go through and it'll set off just by running one command. It'll set off all 175 simulations. And then we'll have another script, a single script where they can run, which will generate graphs of the results. So they can have a nice grid of like the 25, the 5 by 5 parameter sweep showing the different results, so they can compare them really easily. And while they can compare like all the 7 cells for a given set of parameters. So the research group again found this very useful because it was much easier for them than going through and manually doing that for every single cell. Yep, so I think that was all I was going to speak about this example. So I don't know if anyone has any questions about that. Yes, sure.
So how much of that optimization was specific to NeSI?
And how do you mean the optimization? So, this work down here. So
the GPUs and profiling and perform those on any machine.
You could do them on any machine, but you would. So NeSI provides we have profiles installed on the HPC machines. So you could get some of them maybe, but the ones we use here were the Intel ones, which there is a license for, so you'd have to pay for those. So NeSI does provide those for research. So any researcher could go onto our systems and use those profilers, but you'd need to know how to use them, I guess, and that's probably a barrier for some people, is to have the actual expertise to do that.
So it was you and John that did the actual optimization and things like that?
I did the work on this side actually, yeah. So
it was Chris working with the researcher.
Sure, yeah.
And so he was the one that was doing the optimization and the profiling and stuff like that. And so NeSI has a scientific consultancy service that we offer to the research community. And so when you start a project, and I'm going to talk about that in a minute, you can ask for help.
Yep.
And that's through our app support team, which is going to do software installs and things like that. But if you need help customizing and looking at code at a deeper level, we have a team of scientific consultants that can work with you on that. And there's a process for doing that. And obviously, they're kind of a rare resource and stuff like that. So we have to balance that across all the requests we get. But it's a valuable resource that they can probably help you optimize something because they're so familiar with the code profilers and things like that it's probably effective for them to give you a quick turnaround on maybe something that maybe you can go develop and adjust the code, but they can tell you where the hotspots are or things. So there's a bunch of different ways that we can kind of help with that.
Do wheelbarrow loads of money change hands?
No money changes hands. I'll talk about that. I'll talk about that in a second.
The profile that you're using, is it for the whole code or is it for the part which is implemented in the GPU?
Oh, the profile is for the whole. Actually, when I profiled this, it's just a serial version that I profiled before we did the GPUs.
Intel,
VTune, yeah.
Oh.
Yeah.
So do you do that for the GPU code as well, for increasing the performance?
We didn't do the GPU because the GPU version, all the GPU parallelization comes from the VNSCL library. So it's not the code we've written, and it is high performance. It's a community of people developing that code, so we're fairly sure that is good performance there.
Okay.
Yeah.
And the performance that you're comparing here is both on the HPC, you mean that?
Oh, they're both run on HPC. Yeah, both run on the HPC machine. One's a serial one. We got a 2 times speed up by using GPUs instead. Yeah.
What's your rough walk clock time for one run?
For one run, it's around about 5 minutes, I think.
It's a pretty small problem.
It's quite a small problem, this, yeah. But then that's for doing one cell, and eventually we want to model all 7 cells coupled together. But
2 hours.
so, yeah, but then they run hundreds of parameter sweeps. So it's quite a small problem, but it's the number of jobs that they normally run that adds up. Cool.
Any other questions for Chris? So one thing I will point out, you asked if it's running on the HPC machine. Each of the processors, the cores on the HPC machines are just Intel cores. So they're fast Intel cores, but they are just Intel cores. So they're roughly the same core that's running in your laptop. You just have access to 6,000 of them rather than one. And so it's important to understand that if you run something on a fast Intel core on a laptop and a fast Intel core here, there's going to be a performance distinction between those two, because the cores might be faster in particular on the new machines when we get them, but they are just basic Intel cores. And so where you get the scale out is being able to run tens or hundreds of jobs, or running jobs for hours or days or months at a time. So they're going to take a long period of time. And then you can set those going on the HPC machine. You don't have to tie up your desktop machine for those, and you don't have to worry about your desktop machine crashing and all those other fun stuff that hopefully you don't need to worry about. We're supposed to worry about that for you. So can I ask a question? I'm going to talk about accessing NeSI. So does anybody have any other questions before I dive into this? This is where the wheelbarrows of money come in. So can I ask a quick question? How many people have used NeSI before? So 4, 5, 6. How many have used NeSI a lot? Well, relatively speaking. Yeah. More than just logging in and trying something out, and so running some number of jobs over some period of time to try to accomplish something. Okay, great, thanks. So hopefully we can maybe change that, but we'll see. So NeSI is a national organization. It's funded by MBIE in collaboration with the university partnerships. And the way it works, just at a really high level, is the 5 consortium members, so Auckland, Landcare, NIWA, Otago, Canterbury. Thank you. I was going to get there. So they're putting money in to the program. That money kind of gets matched by MBIE. This is my simplified version. It's probably not politically accurate or anything like that. But what happens is MBIE basically is providing matching money, and the collaborators basically are buying access for their researchers. So Auckland has invested in NeSI, and as a result of that, you as Auckland researchers get access to NeSI resources through that collaborator allocation. That allocation is split. 60% of the resources are allocated to the collaborators, and that 60% is divided among the collaborators based on how much money they put in. Auckland is one of the big investors, so Auckland has a fair chunk of that 60%. The other 40% is provided to what we call merit applications, and that's for any application that is outside of its independent of institution. And if you have basically MBIE or I guess world-class funding from an outside organization, that qualifies you for merit, and that gets you access to 20% of the machine. So if you're at another institution that's not a collaborator, you can still get access to NeSI. There's also 20% for subscription, which allows other institutions. Right now, Massey University is a subscriber to NeSI, so they're basically have paid to get access. So they're buying core hours for their research community, right? So typically there isn't a research project or research program to NeSI relationship. It's typically institutional. And a lot of the big institutions already have collaborator allocations, and all academic research institutions across the country have access through the merit and postgraduate, which I'm going to talk about in a minute. So for you as a researcher, There is no cost involved. Your institution has already invested in that, or you as a researcher have invested it through your research funding. If you're part of a core, the MedTech core, for example, is a research organization, funded organization that is eligible for merit. So through that program, you can get access to the merit resources within NeSI. So there is no charge on a per project basis. The institutions and the government have had the wisdom to invest upfront to make it easy for researchers like you to come in easily, so you can kind of get up and running. So you don't have to invest in a cluster in your closet. You can use these resources and hopefully scale up your research as appropriate based on the type of work you need to do. So NeSI basically works on a project by project basis. So it is a shared resource. It is a limited resource, and so those resources are balanced across the allocations that we have. So I mentioned there's 60% for collaborators. Auckland gets, I think it's up around 30-something% of the overall infrastructure. It's around half of that 60, I don't know, something like that. Off the top of my head, I can't tell you. I could tell you more. So Auckland has invested in NeSI so that you can have access to this at no cost to you as a researcher. Sorry, there's a small cost. It's in time, because you have to fill out a membership application for a project. So there are basically 4 types of projects. The first one, and kind of is one we expect most projects to carry out, is a proposal development project. And this is basically, again, cost of the researcher is free, and basically it's providing your project a mechanism for you to understand how to use the resource and use it effectively. We don't want to have researchers coming to the system and submitting a job that takes 100 CPUs and only uses one of them. Right? That's wasteful for you as a researcher, and it's wasteful for everybody else who's waiting for those resources. So we want to make sure you understand. So proposal development, they're typically very short, and it's basically helping you to understand how to use the facilities effectively. If you are a sophisticated computational user already, in some cases, if you can convince us that that's the case, that we might waive this. I probably shouldn't say that out loud, should I? Yeah. Oh, turn that off. Damn. So this is an important step for research projects to go through, because we want to make sure that the resources are being utilized. They're government funded, your university's investing, we don't want to have anybody wasting those resources, so that's really important. Merit-based are basically priority research. They are basically, if they're government funded research funding programs, and if your research is funded by those, then you're eligible for a merit proposal. Merit proposals are the highest priority. So we have a priority scheme that if there's contention for resources, that your projects will be fighting over those resources. If you have a merit allocation, your proposal or your project will be a higher priority than somebody that's in the postgraduate, for example, or the project development. Again, HPC experience is really, really critical. We want to know that you're making good use of the resources, and that's typically done via project development. For all of our projects, we do display projects on our websites. The project title, we ask you to fill in an abstract and a title for your project and things like that. We do display some of that information on our website. Postgraduate projects are available, again, cost zero. For a researcher who is doing postgraduate research at a New Zealand institution. So again, this can be outside of the collaborator allocation. So it doesn't really apply to Auckland graduate students because you're doing, you would work typically within your collaborator allocation. But if you're at an institution outside of the University of Auckland that's not a collaborator, this would be a good way for graduate students to get access to these resources. They are not as high priority as these 2 types of allocations, but they can be of a significant scale. And so if you do have a grad student that's that is trying to get some significant computational science work done, and this is a good mechanism for those people. And finally, there's institutional projects. Again, no cost to the researcher, but your institution is already pre-invested in some way, shape, or form, either through a collaborator or through a subscription. So in Auckland's case, Auckland is one of the large investors for NeSI, and so there's a fairly big chunk of the machine that is available for Auckland researchers. Now, the caveat to that, of course, is there's a lot of researchers at Auckland, and so there's a lot of people using the machines. Right now, we are starting to see some contention on the machines, but the machine there are resources available for researchers, and so I would encourage you that if you have some computational needs and it sounds interesting to you, please feel free to contact us. And I think.
Can I just ask, are there any issues around running commercially oriented analysis projects on it?
So there's two answers to that. If you're talking about commercial codes that have licenses, so that can be tricky as a national organization because quite often software licenses are institutional specific. We can control that on behalf of you, and we would talk to license managers and things that might be institutional license managers and things like that, and only give access to people at your institution access to those files so that they can contact the license managers, etc. So that can be managed. And then the flip side of that is that we have which I didn't actually talk about, there's a commercial component to NeSI. So MBIE as our funder is interested in how we transition the capabilities that we have from a NeSI perspective into industry to help advance kind of the economy and things like that. And so we have a commercial subscriber rate, so we can provide subscription for commercial entities. So if you're doing commercial work, we should probably talk about what the balance is along those lines, but all of that can be facilitated in whatever way, shape, and form makes the most sense. We want to make sure that we meet our funders' objectives and kind of don't break any rules. So that's really what it's all about. Are there any other questions? So hopefully this is. So no money, no wheelbarrows, but there is some time that needs to be invested both to fill in the forms, which hopefully aren't too painful, but also to invest to make sure the people that are actually doing the work are trained appropriately so they're not wasting the resources, because they are pretty valuable resources. So we do run training sessions fairly regularly. Alexandra's going to talk a little bit more about kind of some of the training and in particular some of the software carpentry work and things like that we do. But you can come and learn about the accessing the resources, prepare your project, run your jobs. We try to make it as easy as possible. I'm the solutions manager. If it's not as easy as possible, I don't like to hear about problems. I only like to hear about solutions. But if you have problems, I'm the person to talk to. So that's. I think that's it for my part of the spiel. So, any quick questions? If not, I'll hand over to Alexandra.
While they're doing a handover, I know that the University of Auckland do use a lot of the Consultancy and that's great, and we want to keep that all happening. They are really interested in researchers trying to make applications in the merit and those postgraduate queues as well, which basically means that the University of Auckland's overall allocation would be greater because they've paid for this much, and then if they can also spill into the national allocation, then the University of Auckland's very happy. So, and from our perspective, you're more than welcome to. So I do also consider postgrad and merit applications. The merit ones particularly are getting quite contested and therefore will be a bit of a trophy in the coming years, we'd imagine.
So the criteria for merit is?
To be honest, if you're in this room and you're part of ABI, you're therefore part of MedTech, medtech's a centre of research excellence, and therefore you are eligible for a merit application.
And outside of that, so you're talking about grants and such like, and something which overseas?
New Zealand funded. I'll get the terminology.
Yeah, and I'm the wrong guy because I haven't been here that long.
Grant.
So
It's got to be a contestable research grant, so it's not just one that you just get. You've got to have proven your scientific merit through the grant process.
I think nationally, if it's peer reviewed by a research body, then it would probably be eligible. We don't do peer review ourselves. We leave it to the peer review bodies of the granting agencies to do that.
Something through Canada, which is a contestable reviewed program.
That's like a getting started or something.
Project grants or particularly postgrad. Well, I guess actually, what's become the postgrad?
Yeah, so postgrad.
Fellow stuff is
Postgrad, you could just go ahead and apply for. Yeah. And we can delve into that more if you want.
Good question.
My name is Alexandra Pavlik. I work with Georgina. I'm part of the engagement team, and a large bit of my responsibilities is training. And this is one of the ways how we develop NeSI communities, so empowering researchers and making sure that they not only know how to use NeSI, but that these skills are transferable beyond usage of NeSI. We also work on enhancing collaboration, making sure that the communities, research communities in New Zealand talk to each other. That is part of our mission. So the mission of NeSI is not to run and maintain the big machines. The mission is really growing the computing capability of researchers to ensure New Zealand's future prosperity. And that's written into our documents. So this is our mission. And we work with all research organizations across New Zealand. Training, that's something which I'm going to talk more in detail. Brian talked about this a bit. We also do a number of different events to bring the communities together. Last week we ran Crown Research Institute's coding conference, bringing in CRIs together, people in CRIs who work as mainly developers, but not only, scientists, developers, and developers working with those scientists to discuss. We also, through the work that we do, working with the institutions, we empower the institutions to sort of maintain these communities of practice, best practice in computational research locally. So we're a national organization, but due to the scale, we're not that big. We can't deliver it in every single institution. So we work with the institutions individually so that they can do it themselves. And a lot on what you already heard is the consultancy on the projects that you run on NeSI. That is also building the communities, because that is transferring the skills from our consultancy team to researchers, but also those consultants have knowledge about people who are doing similar things to you, so they might be able to connect you with the peers, scientific peers that work in similar areas. Training. How many people have heard about software carpentry? Okay, 3, 4. Software carpentry that's an international initiative, started over 15 years ago in fact, but really has grown in the last 4 or 5 years. Software carpentry are short, intense courses in computational lab skills for researchers. And there's a core curriculum that software carpentry workshops cover. The model, which can be adopted, it's a flexible model, but the classic model of a workshop is 2 days, intense training, hands-on. You bring in your own machines, your laptops, and we teach you through running particular exercises, things that you do on these laptops with the instructor. Now, the core curriculum includes automation of your tasks, that is teaching command line and working with command line, so you're ready to work on systems such as Unix, Linux, systems that don't have a graphical user interface. We teach structured programming, that is best programming practices that can be either done with Python or with R, depending on the audience and the needs of the audience, and version control. Usually that's Git, and we also teach how to work collaboratively work for GitHub. You already heard this from Chris. This is a very useful skill to have. So this is the core curriculum for software carpentry, and NeSI, software carpentry is an international model, international initiative project. It's actually a foundation right now, which started in Canada originally, and now it's really all over the world. So over 400, 500 people that are involved in this across the world. NeSI adopted software carpentry as a sort of first entry point for training. So we coordinate and develop software carpentry in New Zealand. We run these workshops across the country. The model is that the host is an institution, so people within an institution, so there might be a group at the University of Otago, but we support them in setting up the workshop and running that workshop, mainly through the administration. For example, in Otago, they already done, I think, 3 of these, so they're quite well versed in that. But we're right now, and that's my job, working quite intensely with those organizations in the country that have not yet done it, but really want to. So pictures are, you can see these are pictures on the left. That's a picture from a workshop that was run about 3-4 weeks ago here in Auckland as a part of the Digital Winter Bootcamp, which was a week-long. Software carpentry workshops are 2-day long. And the one on the right-hand side, that's an instructor training that was run earlier this year. Instructor training because these software carpentry workshops are delivered by instructors that are also trained to deliver them. That is a skill that is about how to effectively teach. During the instructor training, we don't teach computational skills, but we prepare researchers that want to share that knowledge with their peers how to do it effectively. So that's also what NeSI does. So that's a kind of a overall umbrella for software carpentry in New Zealand. ResBaz, that's short for Research Bazaar. That's something that started in Australia, and that's more of an event that happens usually around February each year. And we are getting really kind of preparing for that for next year, growing it bigger in New Zealand. That's a kind of a event of 2-3 days long, where you have lots of small training sessions. They're based on software carpentry, but not only. Now, apart from the CRI Coding Conference, we are also contributing to eResearch New Zealand. We're always present there, and that's where we connect with our communities. Research Bazaar, that was so far run in Auckland, Dunedin, and Wellington, but we're trying to make sure that next year we're going to have more sites that will be joining that. We also do advanced training. So I mentioned what is the core curriculum for software carpentry. This is a sort of the entry point. If you're a researcher who writes a bit of code, maybe you just write just enough to use somebody else's code, so use applications that are developed by other research groups, whether these are commercial or not. You might be just needing just a little bit of skill to glue these things together. Other researchers write code almost from scratch. So that's the case study that Chris was presenting, where the code was written almost from scratch, using some libraries, but yeah, you have to have some more advanced coding skills. We do have advanced skills training program, where we teach our communities, researchers that want to use NeSI and want to gain these skills, how to write parallel code. That is sort of more response to the demand. So software carpentry workshops, these are starting to run quite regularly. They're useful for a lot of a very wide scope of research you might be doing using computational skills, not just using HPC. These are really specific for HPC, and also they're specific for a group of users on the HPC. That's why they're more response to demand. So as soon as we see, and that is also thanks to that collaboration that our support team has directly with the project. So what Chris does, what several of other people do, we know when this demand is coming up. So that's this kind of a feedback loop, but we see that researchers need more training in these advanced skills. I am right now working with our applications team to run sort of an regular sessions that will be more about sharing good practice, sharing more knowledge. So these would be things that may not have been listed here. So for example, Chris mentioned continuous integration. That could be one of the topics. We'll be opening these to researchers. That will be in a form of well, they're going to probably be run from different places. We have teams in different places around New Zealand, but we'll be broadcasting these, so you'll be able to join online and learn this way as well. And we have an email address, training@nesi.org.nz. If you have any training needs or questions about training, write down this email and send an email that comes to me, and I will respond to it, I promise. I will either provide you with information about the training that we run, or we will try to think about training that would fit your needs, your group needs, or we might be able to point you to a source where you can find some answers. And this is our absolutely great consultancy application support team, because these are people that really help me with my job. So I'm responsible for training, but as I explained to you, this is how I learned about the training needs. Some of them as well are delivering training, and they're also delivering software carpentry training, and I think some more will be keen in the future to run the software carpentry training as well. And as you saw from Chris's presentation, they will do very fine-tuning as you need it on your code. This is really, this is really something that you rarely get, because you get dedicated support to your project. And this is a very close collaboration, so it's not just you're going to hand over your code and the code disappears and it comes back to you, and you're like, okay, now I can run it. You're gonna have a constant communication, so you will also learn through this process, which is kind of less formalized form of training. But these are skills that you will gain, and these are transferable skills. You can take them further in your research career. I guess that's all we had, and we're very happy to take questions. Yeah.
Do you have any kind of user group kind of connection, particularly across institutions, and even within institutions, particularly around commercial software for commercial suppliers is being used in a research environment? And I find even within an institution, you find particularly there are a lot of individuals using particular bits of software. Unless you're the one looking after the license, you've got no idea who else is using it. And so I don't know what you've got, but let alone across institutions, you're the ones who'd be seeing, who know who's using particular pieces of code. Is there anything in that space?
Mm-hmm. Yeah, so that's part. So I joined NeSI in June. So I keep working on these things. This is one of the things that I'm, together with Georgina, responsible for this, bringing communities together. So when I said we're developing communities, it's not just a training, but just as you're saying, making sure that people that use the same software package or use the same technologies, not just the same research, you might be doing slightly different research scientifically, but you might be using the same packages. So, people using R, they range from, life sciences and the whole scope of life sciences to sociology. So my job and Georgina's job is to bring these people together. And I said we're building within the organizations. That's the first step, to help within organizations build these users groups. And that often happens after the training sessions, when there's a bit of a momentum. People are brought together in a room, and we try to help institutions to have that kind of regular meeting, maybe every 2 weeks. Sometimes every week. At the University of Auckland, there's Hacky Hour that runs weekly. That's mainly attended by research students, but not only. And you have a problem, you can come there and get support directly from somebody who has quite a lot of expertise, but also you meet other researchers that might have come there, and you may, that's how you build that. And this is what we're trying to do right now with institutions, so help them find people who will kind of champion these groups, because we need a bit of that. Cross-institutional, I think that's the next step. We're definitely going to be doing this.
I think there's another step beyond that, which you said you've got a bit of a mandate to try and raise industry use of computing. I'm certainly conscious. I've had a number of students, a lot of postgraduates come through who use NeSI quite extensively while they've been here, and then they go out to companies and get frustrated by only having their desktop or their laptop and so on. And if you kind of get them in that group while they're here or whatever, and try and keep them engaged.
Exactly.
Once they've moved out, that's good opportunity.
Yeah, that's an advantage that, NeSI's in a really good position to help with those kinds of things. I think we're just beginning along those lines, but it'd be really
even good. So they're aware it is an option. So
it'd be good to, if you have ideas around that, we'd be happy to talk to you about how to do that, whether it be at Auckland or across the country.
Yeah, because I think this is a case that I have not yet heard. It's usually, what you described, students leaving, and you would like them to have some sort of a support group that they carry on beyond when they leave the institution. So that would be definitely something.
More isolated then, you know, they might be the only analyst or
Yeah.
whatever the company rather than at least here they were part of it.
At the other end of the scale are you guys involved in sort of teaching parts of formal courses within various institutions, you know, on software carpentry, for instance?
At the moment, there are, we're not sort of routinely across all campuses or anything like that, but where people have asked for us to take a specific course, we do have some of Brian's team who'll go out and take a couple of lectures on a specific aspect, and we're always really happy to engage with groups on that level. So down at Canterbury in the past, we've been involved in some HPC courses in the engineering school. One of our guys, Jean, I think, is involved with some postgraduate courses down at biology. So yeah, it's more of a reactive, sporadic engagement, but I'm really open to it. If you guys are pulling courses together and you've got gaps, then Alexandra is a really good starting point for that conversation, because she'll know what she's across what's within our resources and what's available internationally to draw on, and then we can go from there. And you might end up with Chris in the room, or who knows.
Yeah, I mean, the reason I was asking was because there has been just this semester, in fact, a course that has been set up, mainly driven by Fabiana Cook.
Yes. Yes, so we've worked with her in sort of scoping that, although, yeah, we're not involved in delivering that at the moment. And that's and that postgraduate, not orientation, but, you know, when you start as a postgrad, there's a key skills program, and that is coming through as a clear message from all institutions that there's a need to get everyone upskilled in these digital areas. The other point to note, I don't know if Alexandra mentioned it, is that all the material, the software carpentry material especially, which is around the version control and those really basic things, it's all open source. So, you know, if you run a full-on 2-day workshop, branded software carpentry, then yes, you're better off coming through us and doing it properly and getting the processes right. But if you see that that material would be handy in your course, or you want to run it as just a research group, even do a 2-hour session on one of those sections, then there's nothing stopping you.
So within the ABI, we have, well, actually as part of the core, you know, a doctoral training program, which I think is, you know, ideal for.
Yeah. So we talked to Dave Nixon.
Yes.
Yes. About. Sorry.
Andre.
Andre.
It was Andre.
Okay.
Right, I remember.
Yeah. So we've been talking to him about how we can support you guys with that, and also from our perspective, it's working out how we can support you to do it as a core as well as just as a institution within Auckland, because we're a virtual sort of structure across New Zealand. We know all those challenges. And so we're trying to develop some skills so that we can help other virtual organisations go through those challenges of good VC setups and all that sort of thing.
It's kind of an extension of that, because the other side I see to that too comes back to the community side of it, is being able to make people aware of what courses are being offered. You know, particular institutions are doing something, whether it's small or large, in one space. It'd be great if other people knew about that and go, you know, could send a postgrad, go down there and spend a week there, or whatever it might be, just to leverage kind of what different groups.
Well, it's a good opportunity also to coordinate across institutions. You know, if similar things are being set up in different faculties and different universities, then that seems like an obvious thing to do, to try and aggregate those and you know, get them coordinated.
That's definitely what we're working towards.
Any other questions? I mean, maybe if there are, there's always drinks and nibbles that people can ask if you want. So there's nothing else. Thank our speakers for today.